When solving radical equations, we need to remember that this radical bar means that we're looking for the positive value of the answer. So even though we know that y squared is equal to 64, means that y can equal positive or negative 8. This radical bar is saying simply that I'm looking for just the positive value, which we've got here. So in order to solve this, what we do each time is we square to find the answer. So my answer is just simply going to be y is equal to 64. In doing each one of these, the best thing to do is to isolate the radicals. So again, squaring both sides, this radical is already by itself. We're going to get 9 on the one side, and then the square always outdoes the radical, or this is just 3x, and then we use algebra to finish it off. In this one, we don't want to square both sides, because remember, if we square this becomes a binomial square, and I've got to carry out a whole lot of other stuff, and it can become pretty complicated. So if we don't have to, why don't we just if we don't have to square the binomial, why don't we just isolate the variable? So since it's negative, I'm going to add the radical 5 to both sides, 5x, and add the square root of 5x to both sides. So what I have now is 5 is equal to the square root of 5x. And then squaring both sides, again, the square outdoes the radical, so I have 25 is equal to 5x. And then we can solve to get, and then we can solve to get the answer. One more time, we square both sides, and then we put our variable in. So we're going to square both sides to eliminate the radical here, and then we're going to solve. So we're going to add 3, and then we're going to divide by 2. So this is the basic premise to solving radical equations, but the one thing we have to do is we have to check for inconsistencies, meaning that sometimes, even though we find a value, it doesn't always work in the radical. So let's try these out just for now. So we're going to put this back in. I said the answer is 64, so we're going to put it into the original equation. So the square root of 64 is 8. That checks out. So that is our answer. Putting 3 back in our equation, so I'm going to put that. So I said that 3 times x, well, x is 3, is equal to 3. So that means the square root of 9 is equal to 3, and that does check out. So that is the answer. So putting this in again, we have 5 minus the square root of 5 times 5, and that 5 was x, is equal to 0. So 5 minus the square root of 25, or 5 minus 5 is 0. And again, that checks out, so that is the answer. Let's do it again. So we have, in this equation, we have the square root of 2 times 14 minus 3 is equal to 5. That's the original equation, so we put the x, or the 14 in for x. So if this has got the square root of 28 minus 3 is equal to 5. And we have here 25, square root of 25 is equal to 5. And that does check out, so that is the right answer. So all of these are the right answer, but we need to make sure to check for inconsistencies if there's ever a time when the answer does not work into the original equation. So for these next set of equations, again, square both sides if the radical is by itself, which it is. On this one, you're going to add the 12 to both sides. To solve first, you're going to have the square root of x squared, 6x is equal to 12, and go ahead and continue to solve. This one again, you're going to take the 9 over to that side, and you're going to take the 5 over to that side. So go ahead and solve those equations, and then we'll start checking the answers. So I've completed the next 2 problems, and if you'll see in the purple that I've done the check, and since I put the value in and it works, then this is actually the answer. So x is equal to negative 5/2 and x is equal to 24. Now when I'm doing this one, if you'll notice, I'm taking the 5 over to the other side, so I'm subtracting 5 from both sides, and then we're going to continue to solve. So I'm going to square this side and square this side. Now some of you might be looking and says, wait a minute, I can't have a radical equal to a negative. So we kind of already know that this is not going to have a solvable solution. But let's keep going. So I've got 25 is equal to, oops, the radical is gone, shouldn't write that, is equal to 5 plus x. And then subtracting everything, I got x is equal to 20. So what we're going to do is we're going to put that value in and solve and see if that works. So we've got 0 is equal to 5 plus the square root of 5 plus x, and we just said x is 20. So we've got 0 is equal to 5 plus the square root of 25, or 0 is equal to 5 plus 5, which is not true. So that means this is not the answer. So there is no solution. And again, it could have been a red flag that when I had this set equal to a negative number, I can't have a radical equal to a negative number. So in the same way, I'm going to subtract 9 from both sides, and I'm moving this slightly off to the side to make room, that I've already got a radical equal to that negative number. But you can go ahead and solve down and put the value in and show for yourself that it doesn't actually work. Go ahead and pause the video. So as you can see here, that when I solve this down, we have 29 is equal to x, and placing 29 back into my equation, I'm saying that 0 is equal to 9 plus 9, which of course is not true. So this answer is not valid, so there is no solution. So when we go to solve other equations, what happens if we have something with x's and x's on both sides, or the radical is not isolated? We're going to do the same thing. So I'm going to take this, and I'm still going to subtract 2 from both sides. So I've got x minus 2 on this side, and I've got the square root of x over here. And then, just like before, we square both sides. Keep in mind, though, when we square a radical, it eliminates it and just becomes x. But when I squared this is a binomial squared. It's not x squared minus 4. You have to write the binomial out and distribute it through. So this is going to be x squared minus 4x plus 4 is equal to x when we expand it out. And then what I'm going to do is I'm going to isolate it. Remember, it's easier to solve. We've got a quadratic now, so I'm going to get everything set equal to 0. So now I have x squared minus 5x plus 4 is equal to 0. And then doing whatever method you want. Remember, once you have an x squared, we have to get the x. You can use solving by factoring, solving by quadratics, or the quadratic equation. But either way, you're going to have x is equal to 4 and x is equal to 1. So go ahead and solve each one of these. This one here and this one here. And don't forget to do your check. So when after pausing the video, I'm going to put these values in and make sure each one of them works. And then go ahead and solve these two ones that are same thing. We're going to square both sides, but again, when you square that side, don't forget to expand the binomial. So hopefully when you did the first check, you noticed that not both of these answers worked. Sometimes we say, oh, well, look, it's easy that they're both equal to a positive answer, so they're both going to work. And in fact, the one doesn't. So you can see here when I checked x is equal to 1 back into the original equation, 1 didn't work at all. So this is the thing you have to make sure. Can't just take anything for granted that I found both answers. Not only do you have to find both answers, but you have to check and make sure they work. So go ahead and do the other two. Solving these equations, we notice that, first of all, when we expanded the binomial, this is going to be this equation here, or this expression here, equal to this. Solving any quadratic, if there's an x squared, you've got to set it equal to 0, and then you can choose which method you'd like to use. Same thing here. We squared both sides, and we squared both sides. We have to expand the binomial and then set it equal to 0. So there are some steps missing in this. Back up on this one here. Once we have the two answers here, then you have to go back and check, and it turns out that 16 is the only one that works. Same thing for here. Once we've worked through this, we get y is equal to 5 and y is equal to 3. Unfortunately, y is equal to 5 doesn't work, so only y is equal to 3 works. Now I have radicals on both sides, so this is basically I'm going to have to square this twice. So we squared this side, And this is nice. This side is nice and clean. But this side is still a binomial square, so this is going to take a little bit more of algebraic work. And we have to still FOIL it out. So this is still x minus 7. And FOILing it out, x square root of x times square root of x is x. Square root of x times negative 1 is negative square root of x. And again. And then we have a positive 1 at the end. Now I need to isolate. I need to combine my like terms. And I also need to move all those x's to the side. Well, I've got an x on this side and an x on this side. That cancels out. I'm going to subtract 1 from both sides, so I do have a negative 8 over here. And then I'm going to combine these like terms here, so I have a negative 2 square root of x. Then I'm going to put the, I'm going to divide both sides by negative 2 to isolate the x. So now what I've got is 4 is equal to the square root of x, which means that x squaring both sides will be equal to 16. So sometimes we have to square both sides. Just because we have radicals on both sides doesn't mean it's a lot more complicated. It's just going to take an extra step. And then we have to go ahead and check this in. So let's put these values in to check, and I'm going to squeeze it in up here. So we have square root of 16, that's what we said the answer was, 16 minus 7 is equal to the square root of 16 and then the minus 1 out here. So the square root of 16 minus 7 is 9 and then is equal to 4 minus 1. And it looks like it's going to check out. So this is our answer.